real purpose in life instead of just running around aimlessly or only reacting to the player. And have you ever wondered how games like Stardew Valley create believable daily schedules without manually scripting every single NPC? In this tutorial, you will learn how to build a flexible scheduling system for your own characters. By the end of this tutorial, you'll be able to build a hierarchical task network, in short HTN, that allows you to create daily schedules for your NPCs using reusable tasks. Each task only needs to be implemented once and then can be shared across any number of NPCs, making it easy to create unique routines without duplicating code. A HTN is an AA planning system that breaks high-level goals into smaller executable tasks, allowing NPCs to perform complex behaviors in a structured and modular way. The biggest advantage of an HTN is the ability to create abstract tasks by combining so-called primitive tasks like building blocks. As you can see here, I have a high-level task called Go to the Town Hall, which is composed of several primitive tasks such as turn towards the town hall, play the walking animation, and move to the destination. Here you can see a class diagram of the system we're going to build. It's not really necessary that you already understand every class and what it's doing here, but I think it's good to go through now to give you a short overview of what we are going to build. The core of the system is the HTN planner. You can kind of think about it as like the brain of your NPC, which selects the tasks it has to execute. In our scenario, the HTN planner is pretty simple, to be honest, since it only selects the tasks which are stored in the timetable, given the current time of the day. The HTN tasks are implemented by the strategy pattern, so that the HTN planner can use every task like it's just some random tasks. It doesn't have to know if it's an animation task or a move task or even a complex task which is built from different primitive tasks. For the HTN planner, every task is kind of the same. For now you can just ignore the classes here on the side like location type, world state, HTN state. Those are just there for structure, and I think you will understand when we come to them. To have a clean start, I already created a new project and placed some environment objects here to have some goals to move to, and placed our first NPC here. And yeah, created some empty folders to keep a better structure of the scripts we will need later. At first we will start by implementing the tasks, so those stuff here. The tasks will be the actions which are executed by our NPC, so for example, go to the coffee shop, play the animation to drink coffee, stuff like this. Everything your NPC will be doing exactly. So first you will go create, then scripting, and create your empty C# script. Name it HTN task. Then you will create 2 more, just for example. This one we will call task move to. So this will be the task where you move to a certain spot, your NPC. And create one more for playing an animation. So we will name this task play animation. So after creating your task classes, we'll go ahead and create our data objects and world state objects. So we will create those classes: NPC properties, world state, HDN state, location type, and location entry. You don't need to know what those are for now. We will go through it when we implement those. So let's start with NPC properties. Create a new script in your utilities folder, and this has to be a mono behavior script, since it will be added to the NPC. Then create the world state. Then the HDN state, which can be an NPC# class. The location type. Also an NPC# class. And at last, the location entry, also an NPC# class. We will be starting by implementing the location type. This will have to be an enum, not a class, and it's just a list of the places where NPCs go to. For example, the coffee shop, bus. Now we are implementing the NPC properties. The NPC properties are a data class which stores the most important values and variables of every NPC. For example, the walking speed and the animator. Now I'll add the properties for the variables. Those give me the opportunity not to write getter methods and ensure that other classes can't change the value of those variables. Just be sure to make the setup private. As you can see now, I've added a require component of the animator to the top of the class. This ensures that the object also carries an animator. If there is no animator, Unity will automatically add one. Now we can finally start with the implementation of our first actual task, which will be the move to task. At first we'll need the customizable fields like our target location and the stopping distance. The stopping distance just ensures that it actually ends, because if you just end exactly on the position, it could happen that it never reaches the position, though the stopping distance essentially is like a threshold where we just say, yeah, that's good enough, we are at the target position. And don't forget to inherit from the HDN task, which we actually haven't implemented yet, so we will switch to it. I already made the class abstract, so be sure to also make it abstract. And this is a scriptable object, not a mono behavior class. That's very important. And now we will make the only method of our abstract HDN task class, which will be the execution of the tasks. Now Visual Studio should already give you the opportunity to implement the HDN task abstract class in your specialized class, and will automatically add the execute task method to your class. So now we will start implementing the execute task method. This is the actual method every task needs to implement, where it's handled what the task actually is doing. We'll start by creating the target, reading the target out of the world state by giving the location type to it, so it will return the transform of our target location. Now we will be going on by checking if the target actually exists. If it doesn't, we just return a failure of the state and print a warning so that the dev, in this case you, can see if something is missing here. As you can see now, we forgot to implement the HTN state. The HTN state has to be an enum, and we will fill it with success, running, and failure. So now we can return here the failure state. Now we will implement the actual movement. We will make it simple here, just move the transform with the vector3 move position method to make it simple. You could also, of course, implement your nav mesh navigation into here, but I don't think that's necessarily important for everyone. So we will just make it like this. And now we will do the distance check if we have reached our target position. So we will use the if vector3 distance smaller than our stopping distance. Then we can return the state success because we've reached our target destination. And if that's false, then we will return our running state. For now, we are going to implement the HTN planner in a pretty basic way. Don't make it overcomplicated at first. For now, we will add the list of HTN tasks as that will be our plan. Don't forget to include systems collections.generic. And the next step is to create the variable for the current task, which should be executed. So that's always the one of the plan that's currently in execution. Now go ahead and add the variable for the NPC properties to the HTN planner so that the planner can access those informations. Be sure to make these plan serialized fields so that we can fill up the plan in the inspector. Now add a function called execute current task. This will always execute, as the name says, the current task and call it from the update function, though it will be called every tick of the Unity engine. Now check if the current task is null. Then you can check inside if the plan also has a size of null of 0, and if that's the case, just return, because then the whole plan is executed and the NPC doesn't have more to do. If it's not the case, then we will take the next current task, which is always at the index 0 of the plan. Then in the execution we will call on the current task the execute task function and see which state will get returned. Now add a switch over the state, and if the case is that the state is currently running, then break, because the planner doesn't have something to do. No need to get a new task or anything like that. If the state is success, you will have to remove the first element of the plan and also reset the current task to null. So the next time when execute current task is called, we will pull a new current task from the plan at index 0. And if the case is that the state is a failure, you essentially do the same as on a success. Just remove the first item of the plan and put the current task at 0. But you could also, like I did here, print a warning so that the developer knows something didn't work out correct. Yeah, and that's it. That's our basic implementation of the HDN planner. Now switch to the task move to class and add an asset menu to the top of it, so you can create an actual scriptable object of this. Now go ahead and switch back to the HDN planner and add the awake function. And yeah, we need to initialize the NPC properties, so just use this.getComponent NPC properties. Now go ahead and create a new folder called tasks. Here you will store all your actual scriptable object tasks and create your first one by going to create HDN tasks and move task. Name it move to coffee shop, for example, whatever target you choose. And here you can now select the target and change the movement speed if you want to, the stopping distance if you want to. And now go ahead and add it to the planner. Now go back to Visual Studio and open the location entry class and add system.serializable at the top of the class, since we forgot to do it before, because you won't be able to fill those locations before. Now back in Unity, you should be able to add those entries on the world location, and just go ahead and add for example, the coffee shop, and add an empty object, which should be the target, and drag it here in the transform. So this is the key value of coffee shop, and you will get this transform you put in here. Now you should be able to actually start, and it should be working perfectly fine. The NPC should execute the first task and move slowly to your selected target. So now a little recap of what we have implemented. We've implemented the HDN planner. The HDN planner runs the update loop, always checks if the current task is null, if the plant size count is null, is 0, and if that's not true, then the current task gets pulled out of the plan, which is always plan at index 0. Then we will call the execute task function of the current task. We've implemented the task move to for now. It's the only one. And yeah, we will call, as I said, we call the execute task function. There we will pull the target out of the world state. If the target is null, we will return failure. If it isn't, we will move our NPC towards this target. Then we check if the distance to the target is smaller than our stopping distance. If it is, we will return success. If it isn't, we will return running. So we are back here. If it's running, it stays the active task and nothing else happens, and we will start in the next tick. We will again start here in the update loop, and if we get success returned, we will remove the first item of our plan and will set our current task equals null. And if we get a failure, of course, we will also remove it and try to continue with our plan, and hopefully it's working. Here we maybe should add some more exception handling and be sure our tasks are perfectly working. Okay, so I hope you did understand how our system works and now have a running basic system with an HTN planner working. And I guess I hope I'll see you in the next part.